Hello everyone. So we have been solving NJSLA release items on quadratic functions and their features and solving quadratic equations. But most of the questions till now we saw they were about transformation of the quadratic functions. Again, this is one of the question, transformation of the quadratic function. So pause the video and read the question first. When you can try to solve the question. If you know the answer, it is good for you. If you don't know the answer, let's practice together and let's learn the answer. Okay? So here s of x is given as a quadratic function, which is parabola. As you know, quadratic function is a parabola. So we can discuss about this question. What kind of parabola? Since x squared is positive, so this is a kind of parabola. It has a minimum value. You can find x of symmetry if you want, okay? But it is not asked here. So you can find several features. You can find y-intercept, you can find x-intercept, many things you can find, but we don't need them. So here is the question. It says r of x is obtained by multiplying s of x with a k value. Okay. So in each option here, in each choices, they identify the k. When k is negative number, which is less than 0, when k is bigger than 1, when k is between 0 and 1, what is going on and what kind of new function we have, okay? So let's start with when k is less than 0. When k is less than 0 means r of x is negative version of x squared plus 6x plus 9. Okay, so k is less than 0. K less than 0, any just number you can choose. For example, negative 2 or negative 3 or negative 4. But at the end, a quadratic function I will obtain starting with a negative leading coefficient. So when a quadratic is starting with a negative coefficient, you can guess what kind of graph is that. So I heard you, it is upside down. So when graph is an upside down, we have a maximum point here, yeah? When we have a maximum point. When we have a graph is looking upward, where we have a minimum point is here. One of the features of the quadratic function. Sometimes vertex is a minimum point, sometimes vertex is a maximum point. But in this case, when we multiply our s of x function with negative k, we will have a maximum point. Why we have a maximum point? Because original graph is already facing upward. When we multiply with negative, our graph will be facing, this new r of x will be facing, this f of s of x, r of x will be facing downward. So we have a maximum. So B option will be correct option, okay? So we got this already. Now, when k is bigger than 1, we have some interesting phrases are here. Vertical stretch, you see, and vertical compression, again vertical stretch and vertical compression. What do they mean? So vertical stretch mean, for example, let me explain a side here, okay? Vertical stretch mean graphically. For example, you have a point here. Let's say point 1 comma 1. Point 1 comma 1 is here, okay? So think that there is a rubber band here, okay? There is a rubber band here, okay? This red just piece of thing is a rubber band, okay? So this rubber band is tied or just fixed on the x-axis. This is the x-axis, okay? So when I stretch this rubber band, let me use blue color. So this rubber band endpoint is 1 unit far away from the x-axis. When I stretch this rubber band, double means twice far away from the x-axis, I will get this point, yeah? So if I stretch it double, so I will bending with 2. If I stretch this rubber band 3 times more, I will bending at what? I will bending at 3 here, okay? This is the stretching of the point, okay? This is the stretching of the point on the coordinate plane. So stretching means vertical stretch means making the point far away from x-axis, okay? Compression means compressing that point towards x-axis, okay? This is vertical stretch, vertical stretch, vertical stretch. Let me explain what is vertical compression. For example, there's a point here. Let's say 0.22, okay? 0.22. Here is x is 2, x is 2, y is 2. Okay. So again, I will use rubber band. My rubber band is here. Okay. My rubber band is here. Or you can use a what? You can use a string here. Okay. You can use a string here because we will compress it. Okay. We will compress it. So the distance is here 2 units. Yeah. It is tied to the x-axis. Here is the end. So from this side, if you push, and if you decrease the level, yeah, make it with different color. If you decrease the level here, if you push that string and decrease the level here, so till 1 unit. So the level, the height of the string was 2. Now height of the string became 1. So this point shifted to this point. Now coordinate of this point is 2 comma 1. Okay. You actually change the y value of the point, not x value. This is vertical compression. Okay. Vertical compression. Vertical compression and vertical stretches different from each other. Okay. So since there's a graph x squared plus 6x plus 9, how we define vertical stretch and vertical compression? So I will use Desmos graphic calculator. Okay. In Desmos graphic calculator, I can show you easily. I can explain it to you easily. Okay. When you look at the Desmos graphic calculator, you can use that also very efficient. So our graph is x squared plus 6x plus 9, okay? So in the first option, I will do stretch by multiplying my function by 2, okay? Then I will multiply by 4. As you notice, this black graph is stretch more and orange graph is even stretch more than black graph. So how I can understand that? Put some points on the graphs, okay? Put some points on the graph. As you see here, on the green graph, point is negative 2 and 1. So let me open my annotation. Let me open my annotation, okay? So this distance is 1 unit, okay? So in black graph, distance became double, means 2 units, okay? But in orange graph, distance become what? Distance become here till 4 units because the point is here 4. As you see here, to obtain black graph, the function multiply by 2. To obtain orange graph, function multiply by 4. It means that this point vertically shifted upward twice, far away from the x-axis. Vertical stretch means how you are stretching your graph from the x-axis. So the point x is equal to negative 2, that remains same. But the y value becomes, it was 1, now it became 2, now it became 4. Okay, 4 times stretch. That is vertical stretch. So when we just go back to, just like when we go back to original graph here, oh, sorry, original question here, that is when we multiply k bigger than 1, like 2, 3, 4, so it's becoming vertical stretch, and your graph is what? Your graph is stretch upward, okay? As I explained here, vertical stretch, okay? Among C and D, we selected C option. Among A and B, we selected B option. So almost similar options they have given, but one of them we need to select. Now, when we choose the K number between 0 and 1, what's going on, okay? I try to explain here. There's a vertical compression. So on Desmos graphic calculator, I will show you as well, okay? What is vertical compression? As you see here, the graph, original graph, we have x squared plus 6x plus 9, okay? When we multiply original graph with half, what's going on? You see, there is a blue graph. What happened? Became wider or closer to x-axis, okay? When you just do it with 1 over 4, the red graph is becoming closer to, actually there's a kind of compression from top to down. So how we understand that compression? By putting, by just like finding some points on the same vertical axis, okay? So let me open my annotation here. As you see here on the green graph, the distance is how much to the x-axis? Distance is 1 unit. You see here, distance is 1 unit, okay? But when we go to when we go to purple graph, means multiplying 1 over 2, means this purple graph is, this distance is now half. As you see here, it is half. This is 0.5, okay? is 0.5. And if you put 1 over 4 in front of your function, means your function is multiplied by 1 over 4. Now distance is 0.25, okay? Distance is 0.25. It means that green graph is stretch, sorry, the green graph is compressed halfway, and then green graph is compressed almost 75%, okay? Double of the halfway. So, which means that if you have a quadratic function, multiplying your quadratic function with a number like 1 over 2, which is less than 1, bigger than 0, or like 1 over 4, which is less than 1, bigger than 0, it means that you are doing what? Vertical compression, okay? Your graph is becoming closer to x-axis each time. That is we call vertical compression, okay? So go to the question again back. As you see here, vertical compression, we mention here when your value is from 0 to k, when k is positive. I hope you enjoy the video, what is vertical stretch and the vertical compression. When you search on YouTube, there are some other teachers, they mention about vertical stretch and the vertical compression. You can also check their videos and you can get benefit from them as well. Not only your classroom teacher, just there are lots of algebra teacher on YouTube and they are just recording lots of videos and you can get benefit from those videos also to improve your knowledge. Thank you for staying with me and see you in the next video.